Hello. In today's video, I'm going to talk about monopoly, and I'm going to follow the middle third of chapter 8 in Bay and Prince. The three topics that I want to talk about today are as follows. The monopolist problem, how does monopoly choose its output and price to maximize its profits? Second, I'm going to talk about the technical detail. I'm going to present you with two formulas for the marginal revenue of a monopoly. And finally, I'm going to talk about the um, welfare loss that a monopoly generates. So we're going to look at the deadweight loss of a monopoly and how to calculate it. But before we talk about the monopolist problem, I would like to put things in a perspective, and so I'm going to relate the monopoly model to the competitive industry model that we considered in the last few videos. So if you want to create some kind of a classification of the types of industries that we're looking at in this course and types of industries that exist in the world, one way to do so is looking at the industries by the number of firms that participate in them. And so the uh, competitive industry that we'll look at is the extreme case when there's a very large number of firms and each firm is producing one and the same output. So the competitive industry represents the extreme case when the competition is extremely severe because uh, there are so many competitors. And in that scenario, when firms produce an identical product, if you charge too high a price, all your customers will go to a competitor. And so in this scenario, firms act as price takers. And in addition to that, the most crucial assumption that generated the long run outcomes for the competitive industry was that the entry and exit into the industry was free. So a lot of firms, and no firm has any market power whatsoever. No firm has any power to dictate at what price the trade is going to take place. And so what we're going to look at today, the monopoly model, is the complete opposite of the model of the competitive industry. So in the monopoly model, there's going to be just a single firm in the whole market. And it's not just that the firm will have no competitors, but we are also going to assume that the product that the firm produces will not have any close substitutes. Under these conditions, a firm will have the power to set its own price. So a monopoly has a lot of market power, and to make things completely different from the competitive industry, we're also going to assume that there are going to be barriers to entry. That means that there are no competitors, and if any competitors were to enter the market, they will have to pay huge fees, for example, to acquire a competing technology or to create a network of distribution to compete with an existing monopoly firm. The best example of a monopoly would be a local water utility company. Every person consumes a lot of clean water, and when it comes to buying water from a local water company, there are no substitutes at all. You either buy it from the city or from the town that you live in, or you don't buy water at all because you can't just simply go to a pond or a river and get the water that you need. So since water has no close substitutes, and since there is a single firm in the market, it's clearly an example of a monopoly. And besides, if somebody were to enter the market, say somebody in Sioux Falls decided to competing with Sioux Falls Water Company, well, they'll have to pay a huge price of creating their own water network in the city. And that's going to be really expensive, and this is going to be a huge barrier to entry. So local water and utility companies would serve as the best example because they usually satisfy the assumptions of the monopoly model. But most industries are not extreme. Most industries aren't monopolies or competitive industries. Most industries lie somewhere in between, and they possess some characteristics of the monopoly model and some characteristics of the competitive industries. So we're going to look at the examples of the in-between industries in subsequent videos. But now let's move on to the monopoly and let's look at its profit of maximizing profits. So let's look at a monopolist problem. I'm going to look at an example where the monopoly in place is going to be a metro transit company in a large city. And suppose that it has the following demand for monthly metro passes. The number of passes that it can sell is 240 minus 2 times the price. The cost function is going to be 5,000 for the fixed cost plus 1/8 quantity squared, output squared. Now, the question that we want to ask first is what output level maximizes monopoly profits? And to answer that question, let's first write down the maximization problem. We want to maximize total revenue minus total costs, and total revenue is the product of price and quantity. And to express everything in terms of the output, we're going to use the inverse demand. So whenever you're given the demand in its regular way as quantity as a function of price, you need to solve it for price in terms of quantity to get the inverse demand so that you can write down the profit maximization problem in terms of output only. And so the inverse demand is going to be 120 minus 1/2 the output. And once you've solved for the inverse demand, we can explicitly write down what the monopolist profit is. Price using the inverse demand times quantity minus total cost using the total cost equation. And it's going to look like that. 120 minus 1/2 the output times the output. That's the revenue side of the profits. Minus 1/8 quantity squared minus 5,000. That's the cost side of the profit. And the usual way to proceed is in order to find the maximum of this expression, you want to set the derivative equal to 0 and solve for the output. But the alternative way to do so, or rather another way of writing down that the derivative equals to 0, is to say that we want the derivative of the revenue side, that is the marginal revenue, to be equal to the derivative of the cost side of the profit, that's the marginal cost. So we can set marginal revenue minus marginal cost equal to 0. So the profit maximizing level of output, marginal revenue, has to be equal to marginal cost. And so let's take that second route. Let's look at the marginal revenue separate from marginal costs, and then find the output at which the two meet. What is the marginal revenue? Well, our total revenue is the first term in the profit expression, so that's price times quantity, and the marginal revenue is the derivative of that term. So we just need, I'm taking 2 steps here. I'm clearing the brackets, so I'm multiplying 120 by q and 0.5 q by q to get 120q minus 0.5 q squared. And if I were to take the derivative of that, the first term will give me 120, the second term will give me 0.5 times 2q, so that's just q. So the marginal revenue in this story is 120 minus q. And notice that there is this connection between the inverse demand, price as the function of quantity, and the marginal revenue. And the connection is they look exactly the same except for the coefficient in front of q is twice as high for the marginal revenue. I think we talked about it a long time ago when we talked about elasticity. And so the rule that I want you to recall is that for a linear inverse demand, the marginal revenue can be obtained by doubling the coefficient in front of the quantity term. So 0.5 doubled will give you 1, so negative 0.5 becomes negative 1 in the marginal revenue. What about the marginal cost? If the total cost is 1/8 q squared plus 5,000, marginal cost, the derivative of this expression will be 2 times 1/8 1/4 of q, and 5,000 just gives you 0. So the marginal cost is just going to be 1/4 of the output. The next step is to set marginal revenue equal to the marginal cost. That gives us the equation of 120 minus q equals 1/4 q. And at this point, you can pause the video and solve that equation. And the solution is going to be 96. So the profit maximizing output for a monopoly is 96. And now that we know what quantity maximizes the profit, we can take that quantity, plug it back into the inverse demand to find the price which the monopoly will set to sell its output. And so the price is going to be 120 minus 1/2 of 96, $72. So now we've figured out the profit maximizing combination of output and price, 96 for the output, $72 for the price. The next thing we can do is, again, given our primitives, given the original information, we can illustrate the solution on the graph. So here's what I'm going to do here. The blue line on the graph is the demand function, 240 minus 2 times the price, or alternatively the inverse demand. It shows you for the monopoly for every quantity which price it can sell that quantity at. I'm not going to be plotting any total or average costs in this story. It's irrelevant right now. I'm just going to say that, well, the yellow line is the marginal cost, and remember that was just 1/4 of the output, and marginal revenue is the inverse demand with double the slope, so it's going to originate at the same point, but because the slope is doubled, it's going to decay, it's going to decrease faster than the demand itself. And so for a monopoly, the output is determined by the intersection of the red marginal revenue curve with the yellow marginal cost curve. That intersection happens at quantity of 96. And once that quantity is obtained, the monopolist simply looks at the demand function at 96 and determines the price, and the price is going to be 72. So graphically, the solution looks relatively simple. Given the demand, draw the marginal revenue, find where the marginal revenue intersects marginal cost, that will give you the right quantity, and for that quantity, go back to the demand function to find what price corresponds to it, and it will give you the monopolist's output. Finally, if you go back and plug in the price and quantity into the profit function, you can actually calculate that when the monopolist is maximizing their profits, they're going to get $760 in profits. That's pretty much all about the problem of maximizing profits for a monopoly. The next thing that I want to talk about is two formulas for marginal revenue. And I already mentioned one formula in finding the solution for the monopolist's output, said that for the inverse demand that's linear, marginal revenue is going to be also linear with double the slope in front of the output. The second thing that I want to look at is if I write down total revenue as a function of output in general, there's going to be some inverse demand involved times quantity. And if I want to calculate the marginal revenue as the derivative of total revenue, well, I can apply the product rule. I can say, well, the total revenue is the product of two functions of quantity itself and the inverse demand. So the derivative of the product is going to be the derivative of output times the price plus the derivative of price times the output. That is, I think it's called the product rule for the derivative. And so if we write it out explicitly, well, the derivative of quantity with respect to quantity is 1. So the first term is just going to be the inverse demand. And the second term is going to be the derivative of price with respect to quantity times quantity. And if you look at the second term, and again, I'm referring you to the times back in the past when we talked about elasticity, this second term is just one term away from an elasticity formula, and what's missing, we have change in price, change in quantity, what's missing is the price, so I'm going to go ahead and add it, and so I'm going to rewrite that second term as something elasticity-like, and because I'm dividing by the price inside the brackets, I have to multiply outside of the brackets to keep the expression equal to what it was in the previous line. So that means that I can write marginal revenue as price times price, and inside there is something that looks like the inverse of elasticity. And so if I replace this expression with just 1 over the elasticity, then marginal revenue can ultimately be expressed as price times 1 plus 1 over the elasticity. And don't forget that when you're using this formula, elasticity will be negative, but the negative sign, of course, does not show up here. So if my explanation is not entirely clear, I'm referring you to the textbook, and I believe it's page 294 in the text that you can go and read about the derivation of this formula. But we did it once when I talked about elasticity. I'm doing it once again this time, so at least I expect you to be familiar with it. And finally, the last thing that I'd like to talk about today is the deadweight loss of a monopoly. And so again, let's look at the profit maximizing problem of a monopolist. Here's the graphical solution. Quantity 96, price 72, and quantity occurs where marginal revenue equals marginal cost. That doesn't look great because there are all these additional units of output that can be produced and that can potentially make market participants happier. Because if you think about the output at which the monopolist stops, 96, the marginal cost at 96 is just a little bit short of 25. I think it's 96 over 4, 24. So the monopolist produces the last unit at $24 and sells it at 72. So clearly there are people who are willing to pay a little bit under 72, say 70 or 65, for the output that the monopolist can potentially produce at a cost of 25, 28, 30. So those would be beneficial trades, and if we think about gains from trade, a monopolist producing more and selling it at a lower price than 72 will increase gains from trade in the market. Why would a monopolist not do that? Because producing and selling more would require a decrease in the price, and thus would require giving up a share of profits. So you can realize all gains from trade that exist in this market, but at a cost of losing some profit. And a company interested in maximizing its profits would not realize all the gains from trade in the market. It would forego some potentially good trades because it will just be not worth it. So let's see, what is the efficient output in the market? What output realizes all gains from trade here? The efficient output will be where the yellow line, the marginal cost, meets the blue line, the demand. Because for all levels of output where demand is above the marginal cost, we have a situation when people, that means the consumers, are willing to pay more than it costs to produce a particular unit. Consumers are willing to pay just under 72 for the 97th unit, so in an efficient outcome, it should be produced. They would be willing to pay something like 69 or 68 for the 98th unit, and it will cost just under $25 to produce 98 units, so the 98th unit should be produced. And so we should be increasing production for the efficient outcome all the way until the willingness to pay, which stays on the blue line, meets the willingness to produce, which stays on the yellow line. And so the intersection of the two will give us the efficient output. And in the efficient output, quantity is produced until price equals marginal cost, just like in a competitive market. Here's the condition. The price, I'm using the inverse demand for the price, equals marginal cost, and that gives me the output of 160 and price of 40. So if we want to realize all the gains to trade in this market, we need to force the market to produce 160 units and trade them at 40. And notice then when 160 units are produced, the last unit is produced at 40, at the marginal cost of 40, and it's sold at 40. Going back to the monopoly's outcome, the monopoly produces the last unit at 24, sells it at 72, and reaps huge profits. So clearly, the monopoly here is inefficient because price for a monopoly greatly exceeds the marginal cost. And because of that, we can calculate the deadweight loss that the monopoly generates by calculating the gains from trade that it forgoes. And the gains from trade in the situation will be the area of this triangle. bounded by 96 and 160 in terms of quantity, and the base of that triangle would be the difference between the price the monopoly charges and the marginal cost it pays. So this vertical height is the difference between 72 and 24. That's the first term here, 72 minus 24. So that's the base. The height is the difference between 160 and 96. That's the second term here. And to calculate the area of that triangle, we need to multiply it by 1/2, and we'll get 1,536. So the monopoly generates a huge deadweight loss of 1,500, and the reason, and because there is deadweight loss in this situation, there is a good cause for regulation of a monopoly. If you think about your local utility or water companies, a lot of times they're owned or operated by the city because a lot of times it is easy to regulate a publicly owned company. But I'm gonna give you dots here because the regulation of a monopoly is a very large area of economics, because there are many things to consider in it, and so I'm not gonna give you any policy advices here. If you're interested in policy, this is a great topic and you can read about it. But I'm just going to stop at this point. The basic things that you need to know is that a typical monopoly underproduces 96 versus 160, overcharges 72 versus 40, and thus generates deadweight loss in the form of lost gains in trade. Thank you.